Assalamualaikum warahmatullahi wabarakatuh. My name is Jasmine and NATASYA binti Junaidzi AKMAL. And now, we are from Group 7. We'll present to you the video of our presentation for Control System Project. First thing first, I will introduce you our group member. First, Jasmine and NATASYA binti Junaidzi AKMAL, which is me. Next is AININ SOFIYA binti JOHARI. Next is SYAMILA binti SALIM. NAAJIEHAH binti NORDIN, and lastly USWATUN KHASANAH binti ZAKARIA. Now I will present to you about the introduction. So in this group assignment, we are assigned by our lecturer to model a system in a MATLAB software tool to test our ability of using the software by designing an open loop and closed loop control system. So with MATLAB, we may model and achieve a certain outcome that we anticipate from our system. So in this group project, we need to design a P, PI and PID controller for a closed loop system with appropriate system requirement for transient response by tuning the controller using Ziegler-Nichols method and PID tuner in Simulink. So the Ziegler-Nichols method is a classical tuning technique used in control systems to determine the proportional, integral, and the derivative for PID controller parameters for a system. So, while for the PID tuner in Simulink is a graphical tool that helps users design and tune proportional integral derivative PID controllers for their control systems. Lastly, a graphical programming environment for modeling, simulating and analyzing multi-domain dynamical systems. Simulink is based on MATLAB. Next, we will move to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is NAAJIEHAH binti NORDIN and my metric number is DE220090. I would like to present about methodology, which is in here we are using two methods, which is Ziegler-Nichols method and PID tuner using Simulink. So the Ziegler-Nichols method is a heuristic method for tuning PID controller. The method involves the systematic identification of critical parameters through experimentation to determine suitable proportional, integral, and derivative gain for PID controller. So here a basic step for Ziegler-Nichols methods. So first of all, we have to set integral and derivative gain to 0. Next, we have to increase proportional gain, and last but not least is determine ultimate period, which is by measure the period of the sustained oscillation by which is the time it takes for a system in one complete period. Next is PID tuner using Simulink. So first of all, we have to construct a block diagram using Simulink. Then after that, we have to tune the PID controller using Simulink is we have to double click the PID controller block, and they have a system and button to tune the system by click that button. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is SOFIYA binti JOHARI and my matrix number is DE220085. I will do the result and discussion. For the result, for my part, I have to use the Ziegler-Nichols method. This technique used to tune the parameter of PID controller to improve the response specification of the control system. Okay, this is our group coding. First of all, for the transfer function, we use second order, and then we run the simulation without PID controller. This is the state response without PID controller, or we can say open loop system. And then by using this method, we need to find K, L, T, and A. For coding, this is coding to find K, L, T, and A. For manually, we can get it from the state response before by plotting the state response figure K, L, and T, and then we can get the value A. And then to find PID parameter, which is proportional gain, integral gain, and derivative gain, we need to divide the coding into three, which is for P controller, PI controller, and PID controller. And then after that, we run the simulation, and then we for the P controller. This is the state response for P controller, and this is PI controller. And finally, this will be PID state response of PID controller. Again, to get the transfer response, I will do the one example. We just right click, and then we can find peak response, rise time, settle time, and steady state. For example, transfer response rise time is 0.0344, and then for the overshoot 38.2, and then for the settle time 0.324, and finally for the steady state will be 1. Okay. And okay, and then we can fill this table to find the differences between this. Okay, then we move to discussion. From the state response, for PI and PID controller, we can get rise time, overshoot, settle time, and steady state error. Okay, from this table, proportional controller KP can reduce the rise time, increase overshoot, decrease settle time, and reduce the steady state error. After we add integral controller, rise time, steady state error decrease, and overshoot settle time will be increased. Then we add derivative controller. It will be reduced rise time, overshoot settle time, while steady state error will be remain the same. We can say from this table response specification, we can say that proportional gain can increase the speed and stability of the system response. Integral controller can eliminate the steady state error, but can slow the system response and decrease the stability of the system. While the derivative gain can increase the stability and performance of the system. Okay, that's all for me. Thank you.
Assalamualaikum. My name is SYAMILA. For the next simulation, I will present about the PID auto-tune method for open loop system and closed loop system with P controller, PI controller, and PID controller. Okay, first I will show you the open loop system. This is our block diagram. For step, the final value we use 100. Then this is our transfer function. The scope will generate the output graph. And when we run the simulation, okay, this is our output graph for open loop system. Next, for the closed loop system using P controller, this is our block diagram. The final value for step we still use 100, and proportional value we use 1100. This value we get from the simulation of Ziegler-Nichols method. Then we tune to get the output graph and parameter of transient response. Okay, the graph show that the block response and tune response. The block response is from the system that using Ziegler-Nichols before tune this system. Then we click the show parameters to get the transient response. This is tune and block. Yeah, and this is transient response. Okay, we close. Then for the PI controller, the same procedure we do, but change the proportional and integral value. Just put the value that we obtain using Ziegler-Nichols to see the different output graph. The same method for PID controller, but change the proportional and integral and derivative value that we obtain from Ziegler-Nichols to see the different output graph. Okay, then we do the PID controller. This is our block diagram PID controller, and click the step. We use the final value is 100, and when we click the PID controller, we need to change the value P, I, and D, the value that we obtain from the Ziegler-Nichols, and the filter coefficient N we used 100. Then we tune to get the step response. This is our graph step response. The difference of tune response and block response, and click the show parameter to get the transient response. This is different of value TR, TS, and overshoot. Okay. In PID auto tuning, a combination of proportional, integral, and derivative gain is explored to achieve a balanced response. This method provides initial parameters estimate, but fine tuning may be necessary to meet specific application requirement. The choice between the two methods depends on factors such as system complexity, desired performance, and the availability of detailed system models. That's all from me. Thank you.
Hi, Assalamualaikum. My name is USWATUN Hasanah binti ZAKARIA, and my metric number is PE220091. Okay, for the conclusion, in completing our group assignment about controller principle, we can conclude that the analysis of system parameter including rise time, setting time, and overshoot is essential for evaluating the responsiveness of a control system to input changes. The application of proportional KP, integral KI, and derivative KD controllers has distinct effect of these parameters, influencing the system speed, stability, and steady state error. The Ziegler-Nichols method and PID auto tuning are valuable tools for tuning controllers, with the former emphasizing responsiveness and the latter seeking a balanced trade-off between speed and accuracy. While the Ziegler-Nichols provide initial parameters estimates, and PID auto-tuning allows for more precise adjustment to meet specific application requirements. The choice between the two methods depends on factors such as system complexity, desired performance, and the availability of detailed system models. Ultimately, achieving optimal transient response characteristic requires careful consideration and fine-tuning of controller parameters. And I think that's all from me. Thank you.